Hello everyone, I'm Pim and I'm with Sagar. Today we would like to present our presentation on Bureau record digitization, or in other words, it is text extraction from Bureau record card or scan image. So in this presentation, we will first starting by stating the problem that we have and project scope, followed by project milestones, which is how we develop this project. Start from exploration the data, from classification model building, image processing, text extraction, and evaluation. Then we will end our project with the project limitation and future scope. Let's first start with the problem statement. So we are given input, which is in JPEG format, and it is actually a scanned image of the Bureau record card. The objective of our project is to build a text extraction model to extract information from scanned image. Here you can see the example of the input. We have different type of form, and in each form there is some variation that causing the extraction to be more complicated. Our objective is to finally get the text from the card in this format, and these are the target field that we would like to get the information from. Before we start the project, here are the assumptions that we made in order to make the project work correctly. So first, an Anaconda platform should be installed on the local machine. You should have AWS accessibility. There are only 5 form types in the dataset. Knowledge base is available to obtain, either provided or self-created. Cards have at least 5 fields, including name, date of interment, section, letter, and grave. Also, that the values in each field has pattern or format. For instance, the date field, it has some format as shown here. Now we will continue with the project milestone. So first, exploration. We are given with 120 dataset, and we classify different form based on the different in the data. Even small different makes it another form. For example, here the form 0, we can see that the age is on the first line. However, on this form, the age is in the second line. That's why they are different. And then this is the third form and fourth form. Because of the line, we classify it differently. And the last one is the handwritten.
So now for the workflow, we have divided into 4 different parts, which is starting from form classification, which returns the form type, and based on that form type passed as an input to image processing task, helps to process each form type differently based on different image processing tasks. Later, that processed image is passed to text extraction block, which involves using AWS API to extract text and then later cleaning the text, and finally we evaluate our result based on custom evaluation. Starting with form classification, we have defined a convolutional neural network model using Keras. So the model or the architecture has 3 hidden layers which comprises of convolution block, ReLU, max pool, and dropout. Later, that is connected to a dense layer, which is fully connected layer, which has 2 blocks of it, and then using softmax to finding out the probability of the predicted class. On the below image, you can see that we got a training accuracy of 97%, whereas the validation accuracy is around 84. So testing based on 5 different image types, we were able to correctly predict 3 image types, which were 1, 2, and 3, and we were not able to correctly predict 0 and 4 because of the low sample size. But because of the minor difference between 0 and 1, which is just different block orientation, we came out with a technique in which we extracted the text from AWS TextRack and figured out the orientation of different form or the field values, and later classified them as 0 and 1 separately, thus improving the accuracy of overall model even if we had smaller sample size. Later, we come with the image processing task, in which we have divided into 3 parts. Let's start with the basic image processing task, in which we have converted all the images to black and white, remove all the white spaces from them to align it all at the same pixel. The second image processing task or additional image processing task comprises of cropping the images, which involves cropping only fields which are important or interest to us, and later on resizing it to increase or magnify its size or the pixel density. And adding on to that, one more task in additional image processing is adding white space to the image, which results in padding images with the white pixels and making it into a square. Later on, this after this two image processing task, it is passed to AWS Text Rack.
So here is how the AWS text track recognize text. You can see the box that it recognize. So we think that from this we can exploit the pre-built machine to extract the data from image. To do so, we use API and we code it in Python to get all the extraction, and the result is shown here below. From this output, we only pull the text and confidence into our result in order to get the text extraction from the image. So after we get the text from AWS, we clean the text. We use regular expression to create a pattern, as we assume that in each field the values follow some certain pattern, for example date. In this code, we're trying to match the pattern. If it doesn't match, then the character will be removed. For example, if the date format has character, those character will be removed and we will left with only the numeric number. After we clean the text, we evaluate our prediction by using these two metrics, which is the correct prediction ratio and incorrect prediction ratio. For correct prediction ratio, we take the total character correctly predicted divided by the total number of character predicted. And then for the incorrect ratio, we take total character incorrectly predicted divided by total number of actual character. The example of the result is shown here below. For example, in the date, you can see that the first one here, it get incorrectly predicted, and you can see that the correct ratio is 0.8 and incorrect is 0.1. However, when everything is correctly predicted, the correct ratio returns 1 and incorrect becomes 0. So the objective of this is to maximize correct prediction ratio and to minimize the incorrect prediction ratio. We also come up with a technique to see how accuracy improves over each iteration, and we define each iteration here. So the iteration 1 is just the basic image processing, and then we pass it to AWS and get the text, and then we evaluate. And the second one, we just add additional image processing, which is resizing and padding on top of the previous one. And the last one is the text cleaning. So here is the result after we do 3 iterations. You can see that after each step is taken, the accuracy improves and the CR become higher and IR become lower, which match our objective to maximize CR and minimize IR.
After evaluation matrix, we came up with some limitations and future improvements. So some of the limitations are that we were not able to correctly predict the fraction part. We were having issues with classifying handwritten images and also extracting text from them. And there are some flaws in the way we are cropping the fields or creating a bounding box, which leads me to a future improvement block in which the bounding box can be improved by creating an unsupervised model to crop the target field and improve it over time, and also creating an unsupervised model which selects bunch of image processing tasks and evaluates using evaluation metrics such as correct ratio and incorrect ratio and improve over time. Another improvement which we can think of is trying different image processing tasks for handwritten and text, handwritten and fraction text extraction. For example, deslanting the slanted handwritten images. Let's start with demo. So let's start with pipeline. So we have divided pipeline into three different parts. First one is form classification, from which we classify the type of the form and pass that type to the text extraction. And later, after extracting the text, we are appending it to a table with defined targeted field. So the model pipeline includes iterating over each image and extracting the targeted field and applying the processes which we discussed before, which includes basic image processing technique, additional image processing technique, and also cleaning of text and appending it to a summary table. Here we are loading our form classification train model, which is saved in the JSON format, and we are also appending or loading weights to the model. The next code line which you can see is test demo, which reads the file which has some defined image datasets and the form labels. After loading that file, we are passing that to the loaded model to predict the classes, and it is predicting all those classes correctly, which are type 1, 3, and 2. And later passing that to the model pipeline, which in at the end processes our image, extract the test, and that is saved to summary pipeline, and that summary pipeline data frame is saved as a CSV format. So here is summary pipeline generated, which is divided into five different parts based on different targeted fields. You can see that it is divided into actual name, actual predicted name, confidence score generated by AWS, text track, correct ratio, and incorrect ratio of name. And it goes on for rest of the six field. This is the form which is generated from our model pipeline. Thank you.